Hello everybody, welcome back to my channel. Today we have the autopsy of a Balmar alternator. The model of it is 6120 SRIG, 120 amp, 12 volt DC, ignition protected. Now this one it's a gift from one of my friends to try to see what's going on with it, and if I manage to recover it and to fix it. Now I desolder the three from the case and just split it into halves. The first thing, it is the dust. The first thing you notice is the really dusty interior. Now this is from the belt, maybe the pulley, the original pulley. I don't have his pulley because he kept it on board, and I don't have also the nut that goes on the top of it. This one is not his. But the problem with the dust is the one from the pulley. Now on the other hand, we have the rotor, and inside there are the brushes. This is the lamp terminal. It used to be soldered here. It can be soldered with any one of the three phases. This is only a cover that used to stay here. Here you have the negative terminal that's insulated from the case of the alternator. You have the positive, and then this one used to be the lamp. And then here on the side connection you have the various connections in order to use the internal regulator or use an external regulator. This one, this one is like the MC614 regulator that is external, and you can use it as an external. Now I will go on dismantling, and I'll be right back to you after I took out the rotor. In order not to ruin the brushes, I don't have this key here with me, so I just took out one of them like a gypsy with the pliers, but I will bring the right tool to take them out. But in order not to ruin the brushes that stay inside here, since I cannot take it out because I don't want to ruin the screw's head, just put inside a small piece of plastic. This is a small trick, or in some of them you have the brushes all the way back and you have a small hole. On the ones that you will install afterwards, there is a small hole with a pin. Now in order to reinstall them after I took out the rotor, I will make a small hole from one side to the other and put a small pin. That way you can assemble everything and then just pull the pin out, because the brushes are staying. They have behind them two springs that keep them touching on the rotor. Now I will take it out and be right back with you. Now, as I told you, the two brushes slipped down, but they did not do any damage because the plastic sheet was in the middle. Those brushes stay, they have two springs behind them. Now, okay, in order to reinstall them, see, if you have to reinstall them without taking out these two screws, these three, and just take everything out from here, the best thing is just to push them all the way back, make two small screws from one side to the other, like 1 millimeter, and just put a pin, like a paper clip or something like this over there. That way they will stay inside. You can put everything without risking to break anything. Now, the thing that you have to see here, all this black, it is dust, but what you have inside here, this is the belt dust you have here, but the one you have in here, this is the most dangerous dust you can have inside a boat. Now, if you watch carefully, there is an insulation that keeps the bearing, keep them insulated, but this dust, this goes here inside the diode block, goes around here, and when the alternator spins, the dust stays on. The alternator, it's connected to the positive battery. Some of them are always connected, some of them are through an insulator, a diode insulator. Anyway, when the alternator is producing energy from the 3 windings, wires, and from the diodes, this small dust, the one that's for the brushes, it is conductive, really conductive, because the brushes are conducing the electricity towards the rotor. Now, when you have electricity inside, I cannot manage to touch it. It conduces the electricity. I cannot manage to watch the camera and do the same thing. Anyway, the brushes are conductive. Maybe I have some problem with the leads of the tester. Should be 006. Anyway, this dust that's going around the alternator will conduce electricity towards the rest of the boat. So that it is a problem with the corrosion. Sometimes can give you really big problems with the corrosion. And inside these bearings, although they are shielded, they have like a part that's protecting the grease. Sometimes the dust finds his way in and it will consume, it will damage the bearings. But we have some dust here. Anyway, that is one problem. The other thing about Balmar alternators, this is the plastic that I put in order to protect the rotor. This alternator worked for a little bit since it's really dusty, but if you watch it, it has really small consumption on the rotors. This means that the rotor together, it's a good quality. On the cheap Chinese ones, after like 1 or 2 years, it gets like a really big ditch where inside the brushes have worked. Then the second particularity of the power alternators, either it is a Balmar or a master volt alternator and so on, these bearings that you have here, this is in 6303 LX. These ones should have the grease at higher temperature inside. So even if you take a normal 6303 bearing, these ones, the original ones, if they are original, should have a grease like 120 degrees C inside. Now I have no idea if these are the originals or not. Anyway, now we measure the three windings inside, and they are all 3 equal. Now I did not measure them with a normal multimeter, but with with my smart tweezers, measure it on the air, that is and then on the inductance, and they're all equal. Now this one at this point it's good. One of the problem is the internal regulator that gives problems, is not properly working. Then we measure the rotor. It has 4.6 ohm and doesn't have continuity from the rotor towards the case. Same thing here. The metal case and the windings, they should not have continuity. Now, since the rotor is good, the windings are all good, the regulator, it is not working, the original one. Now I'll take it apart and show you the numbers. And probably one of the diodes. Now, in order to measure it, the first thing, you go on diode, and then go from positive to negative. This one is the positive, the left one is negative. And put the positive on the positive, negative on the negative. Then switch them. In one way should not conduce, in the other way should conduce. Now the diodes, let me grab a pen and show you really fast. Now this is the symbol of a diode. The role of a diode, it's let the current pass in one way and do not let the current pass in the other way. Now this is the symbol of a diode. This is called cathode. This is one, it's anode. The anode is the positive, the cathode is the negative. Now if you have an alternating current, if you take like a battery and you go to push the minus from the battery, go through the diode, and then here you put a light bulb, and then going back to the positive, the current in this way will pass through the diode from the cathode towards the anode, the negative. If you invert and try pushing the positive from here to here, will not pass. The same thing happens. This is a diode, okay? This one is like another type of diode. It's bigger. And those that are inside here are also diodes. They have one big end that stays on the metal part and a small end that's connected behind this shield, this guard that it's putting off here. Now, you have a stripe on the diode. The stripe, it's the cathode, the negative, and the other side, it's the anode. Now, if you put them like this, okay, one stripe, the negative, one stripe, the negative. This is the drawing from here, okay, with the negative. Now, if you try to push the positive from here in this side, will not pass, but the positive will pass from here towards here. Now you have two diodes. One side it's the positive main bus, that is this one. On the other side you have the negative, that is this one. And then everything repeats for 3 times. This is connected with this one, this is connected with this one, and another one. So in total we have 6 diodes. 2, 4, 6. Now this centerpiece with this centerpiece with this centerpiece are these 3 that you have here from the windings. 1, 2, and 3. The windings. These windings generate alternate current between this one and this one. You have one phase. Between this one and this one you have the second phase. And between this one and this one you have the third phase. It's 3 phase. And here you have alternating current. It means that the positive with negative invert themselves each time the rotor passes by. When one of this one is passing by, will give you positive. When this one is passing by, will give you negative. Now if you try to measure it from this side, going to here and going to here, will let the current pass with the positive going from there. If you invert them, will not. So when you measure between the positive and negative, in one way should let the current pass, in the other way should not let the current pass. Now you can measure the individual diodes one by one. So you go here, we have like the positive ones, they're all to the same insulator. This is one insulator, it goes behind this diode, it goes there, and you have an insulating material, that's the pink one, and you have the other insulating material towards the case of the alternator, that's the other pink one, that goes on the negative diodes. And the other one are positive diodes. Either if they are like the same, you have the case like this with the big metal part and the small part. One of them has the cathode on the big part, the other one has the anode on the big part. So now when you go to measure it, you take one on the body of the diode and the other one on the center. In one way is not conducting, you should go do the other way. In this way it is conducting and it gives 0.55 voltage drop. The measurement where you have on the diode, on the instrument, you have the diode symbol, it is the voltage drop that you have inside a diode. Various diode types have various voltage drop. Now once you measure all the diodes one by one, you know if you have a problem with one of them or not. The measurement of the power drop should be equal for all of them. Now in theory, if you put them two in series, you should have the double of the voltage drop here. So when you go measuring, you should have the double of the voltage drop. If by chance here you don't have the double, or one of the diodes when you measure it doesn't have a power drop, like all of them have 0.5, no? If you go and measure it and it is 0, 0, it means that it's passing through, or doesn't measure anything. Or if you go measuring from here to here and you have 0.5, like only like one of them, it means that one diode it's short and is passing through. In this case all the diodes seems to be okay, so the problem seems to be the the internal regulator. The nicest part of this type of alternator on the Balmar that it has an internal one and an external one. Even if the internal stops working, you should be able here with one of the wires just put an external regulator and have it working. In this case, when I've done the measurement, the pin from here to the brush, so this is a P-type, you have the negative, it goes with a wire that goes directly on the brush and is soldered on the brush behind, and you have the other one that goes inside this regulator, and it has an output, should be one of these. It is the output in order to connect an external regulator. In this case we have an interruption between this one and the brush itself, so even if you put an external regulator, will not continue to work this alternator. Now in this case I will just clean everything up and try to order a new one. If not, I'll just leave it in place disconnected, solder a wire and take a wire out with a fasten that will connect inside the original harness. And this original harness also have the white one. The white one, it's the tack that it's like RPM measuring. So I will take a white wire from one of the three. You can take every whichever one of them and just send the signal tack. What's happening? The tack signal, it's the signal for the RPM meter that you have. But in this case, in order to make it work better, the external regulator, it needs also the tack signal. So that's it about the Balmar. This is the autopsy. Failure from the internal regulator. This is a really nice power alternator. The heating and the cooling of the alternator has these two systems of cooling inside. It is a really lovely system of cooling. I will pause and show you some other type of alternators that I have inside here. Now this one, this is a 200 amp hour alternator. It is from automotive, from some kind of car. I have no idea which one of them. It is really similar with the Balmar. The Balmar one, it says 120 amp at 12 volt. This one is rated 200 amp at 12 volt. Somewhere I should have the serial number from the back. This one, it is a lean alternator. It has only one wire, that is a data, and is digital commanded. There's a particularity of this one. So this one, it's rated for 200 amp hour, but the 200 amp hour, if you watch the wire size with the Balmar it's a lot thicker. This 200 amp hour, it is a cold rating. That 120, it is a hot rating. This alternator, the maximum output will be like 170, 180, but in only 120 will work like almost at the minimum RPM of the engine. So for a boat, it is really important. Now, since I'm a hoarder, this one, it is an alternator that it's 120 amp, 12 volt. It is not a proper power alternator. This one I bought it when I was having the Nani, when I had the Nani engine. It also goes like the older series of D255 Volvo Penta, or like the MD 2030, 2040 and so on, because it has this only one leg attachment. Should a little bit just eat up one of them, because it's not aligning perfectly with the engine. So you have to do the alignment in order to install one of these on the newer, on the Volvo Penta. If you watch the winding diameter, this one also it's really thick, but this one with this type of cooling fan, it is rated for 120, but it will carry maximum like 70-80 sorry, 80 amps at maximum, because it will overheat. I've installed inside a temperature sensor for the Balmar directly on the diodes on the positive terminal. This one has the negative connected to the case, so the case is grounded. So the hottest temperature inside, you have it on the diodes on the positive one. So that's why I've installed in the times the temperature sensor. This one still has the original regulator installed. This is an internal regulator, but on most of them I cut off the regulator part and just keep the two brushes connections, and that way can be externally regulated. So you can install on that one a Balmar external regulator. Why I like the Balmar in particular, it's that even the old MC614 or like the AR series and so on, they have the temperature sensor for the alternator. Now, when you're using the new lithium-ion batteries, it will put a lot of strain on the alternator, and most of them will melt them. This one, if you connect it with his original regulator and you have a thick wire, like a 50 square millimeter, so you don't have a lot of power drop from the wire from the alternator to the battery, because in most old boats, the power drop on the cable, it's like the worst thing you can have. But in the lithium batteries, when you have them, it acts like a protection, so will not put so much strain on the alternator. Now this one I've made a couple of more holes for cooling. This should have gone on my old Nani engine, but since I sold the engine and passed to switch to a new engine, I have it around here. This is the original Nani alternator that I used to have, and if you watch the quantity of wire that it has inside and the way it's built, it is similar, a lot similar to the Alt S. If you watch the top part, it is from one of these, the top part, because I kept they are so similar one with the other that I kept the original blue part from the Nani. I installed it on the alternator, that way I didn't have to file here just to bring it to the right correct alignment on the pulley. This one should be like a Lucas or something like this. I don't even remember which one of them it is, but if you watch the wire quantity, this one has another winding, like the double of the windings that you have in here. This one, it's exactly double. Now, one thing, this one, even these ones are the old type wiring when you have this mesh. The new one have hairpin, but that's a whole different other story. Now, all these alternators function and are working in the same identical way. They have the diodes inside. They have the regulator, the voltage regulator, they have the brushes that go there, they have the rotor, and everything is working the same, exactly side. Now the difference between this type of cooling and that type of cooling is that this one, the internal one, works a lot better, it cools a lot better the alternator. Now, thank you for watching, and just let me know in the comments if you want to see something about the voltage regulators, external voltage regulators also. I might have an even more interesting solution. Another solution that we can have for the new lithium batteries in order not to melt the alternator, if you don't want to switch. Now the proper way, it's just take yourself an external regulator, a really nice power alternator, the one that's born to be power alternator, like a Balmar, like I don't know, a Master Volt, an Argos. You could take an automotive 200 amp one and limit it to like 120 with an external regulation. But there is another solution. Victron Energy invented this thing that's called Smart BMS GL12100. Now this one is born in order to be used with their own batteries. When you connect these M8 connectors, they call them, to the battery, and the battery speaks with the BMS and uses it as an external BMS. Now you have the battery, there is this fuse here, and you have an alternator input, this one also. Now changing the value of this fuse inside here, you can limit the current that it draws from the alternator. So if you do not use the BMS function of this thing, you can only use it as a limiting current device from the alternator to the lithium battery, in order not to blow up the alternator, not to melt it. So this is another solution. You will need a hacked cable, so buy an M8 cable and just hack it. There are a couple of modifications that needs to be done in order for it to work, because, and that way you can make it work with any kind of battery. You can make it work with a self-built battery if you want. A lithium ion is the one that I'm powering the lab with. This is another solution. Let me know also if you want to see like a video detailed on how to modify it and how to make it work with any kind of battery, because from the factory it works in theory only with the lithium batteries from Victron. In practice we can make it work with any kind of battery.